So Brent and GroupBy organization, thank you for this opportunity. So I've been involved with Columnstore feature for 2016. It used to be run by the PDW team. If you recall the device which was changed to ASP. So for them, Columnstore was a very important feature. So they drove the 2014 development of Columnstore, and then it actually was given back to us. And so the Columnstore that I've been involved with is learning from the customers to understand what challenges they were facing with Columnstore technology in adapting to their workloads and bringing those solutions in 16. And I must say that with 16, um, the column store is quite complete. I mean, there are of course missing functionality, but it's in a very good space right now. And because of this, as you will see, we got a lot more interest from customers to adopt this technology to improve the performance of their workload. And what I wanted to cover, I mean, everybody knows, I should not say everybody, but most people know the column store technology is for analytics workload, data warehouse, you do aggregate, stuff like that. That's column store. And so it's a no-brainer. Well, if you have a data warehouse, just use column store and life is good. So what I wanted to do was pick few customer cases which you may not think of column store as a first solution. And what amazes me is that even I tried column store for those solutions, with some reservation. I said, let's try it. And it turns out it was very successful. So if I have one message for the audience here is that just don't think column store as a very narrow solution for analytics. Just be open-minded and see scenarios where it can be useful. And hopefully the slides that I'm going to present here will give you some ideas about that. So I assume that people know what column store is, and I think in the audience, if you don't know what column store is, I'm going to give you a very, very high-level description what it is. And my recommendation is to do and watch a couple of online presentations that have been done by Nico or myself or anybody else, and you will get the basic understanding. And then I think you can watch this video after that, right? So what is the benefit of column store? And I want to have a very summary thing to say what we have done for column store in 2016. And the success stories that I've chosen, these are the customers who are in production with column store 2016. So Damon is a health insurance company in UAE. First American Title is a financial company in Los Angeles. M-Files, I think they're from Finland. FIS is a finance company in, I believe, New York City. And there's an insurance company, but I'm going to skip that part. So 4 customer stories, okay? So first thing I want to showcase you, in case you don't know much about column store, why column store is such a hot commodity. And I say hot, I mean, if you look at a lot of migrations that are happening to 2016, there are many big ones. One is column store because it is giving amazing performance. Second one is R, which is, the R integrated inside SQL Server. And of course, a lot of supportability things we have done. So column store is a very, very powerful feature, and we are seeing a lot of migration to 16 because of that. So let me quickly show you a demo. This demo actually I've shown many times, but I think it shows the value of column store in a pretty big way. So we have this database called AdventureWorks DW. You must have seen DW 2014, 12, and this is 2016. And one funny thing about this one is it says CTP3, right? Now, ideally should not say CTP3. This is actually the final version. And there is some contention point between multiple teams to decide whether we should keep it as CTP3 and have, we have Worldwide Trader as a new database, So don't think of CTP3 as something half-cooked. This is pretty much fully baked database, all right? And it's available for download. So I'm going to use this database. And I'm running behind the scene a SQL Server, I think 2016 SP1. And if you want to see, I can just do select star formatted version. Brent, one question I have, how much time I got?
As much as you want. They go between anywhere between an hour to 2 hours.
All right. So I'm just gonna go easy on this one. I'm gonna take my time here.
Cool.
But I promise to finish before hour and a half. And if people have questions, how do they ask questions?
Oh, they have both Slack and GoToWebinar, and then whenever they pop up, I'll interrupt you if it works at times of work.
Right. So as you can see, I'm running a SQL Server 2016 SP1 with CU2, and pretty much it was released on March 6th. So that's the version I'm running. And I think it is available to anybody who wants to try it out. So now what I want to do is run a semi-complex. I mean, I'm sure in your production environment, you guys have much more complex queries, but this table has a fact table, which you see here, reseller fact table, and there are 3 dimension tables, right? So there are basically adjoining 4 tables, and with a restriction that I want to look at the data of 4 years, like 2006 to January 1st of 2010, any group by, sales, territory, region, stuff like that. So this is like a common query that you will see that is running in a data warehouse scenario. And this query that I'm running, in this case, the fact table is a row store. And so this is if you have not adopted a column store technology in your data warehouse, you're running with row store. In many cases, I mean, I remember from 2008, we recommended people to use page compression for your row store, to minimize the I/O that you can need to do to run a warehouse kind of a query. So in this example, actually, I do not have page compression. I just wanted to show the extreme of what can be achieved, because on my laptop, I cannot really run big workloads. So basically, this is the column row store table, and it is moody. Sometimes it takes 30 seconds. Sometimes it's like 1 hour, not 1 hour, like over a minute. So here you're saying it's taking 53, 54 seconds. So what I'm going to do, I'm going to stop it because I don't want to waste anybody's time here. So basically, it is definitely taking more than 59 seconds, right? In the row store. So what you can do, let's say you had a data warehouse workload and where some queries are taking long time. And why this is so important now? Because the data is growing. So some query that was running, say, in 2 minutes yesterday, and now your data has doubled over last year, the same query may take now 4 minutes because, at some level, the query performance will be proportional to the size of the data that it has to munch, right? So what you can do is you can take this fact table and just say create a clustered column store index, right? It is a clustered index in the sense this will be the master copy of the data. You're just saying create clustered column store index on that fact table that I had as a row store. Now, of course, if you had a cluster index, the row store cluster index on that fact table, you will say drop existing, right? So you just create that index. Now, this index is a bit more expensive to create because not only we have to, create that index, we have to compress the data. So what we find is the create clustered column store index takes, I think 1.5, like 1.5x of the time it will take you to create a cluster index, something like that, right? So you create that index. And now what I'm going to do is I'm going to run the same query, right? Same query. And notice what I changed here is my fact table has changed. Instead of, row store, I'm just saying it is CCI, right? I'm going to run this query now. And what you will see is that this query is exactly the same. All I did was I created a column store index on it. And for some reason, so this query finished here in 11 seconds, okay? Now, so at least we can say that the query ran 6 times faster than the previous one. Remember, previous one I had shut down after almost 59 seconds. So here is the benefit. You are able to improve the performance of your query 6 times on my laptop without changing your application. And I think this is the biggest deal for us, because a customer who wants to upgrade, say, from 2014 or 16, or wants to use Column Store, they do not have to change the application. They have to, of course, create the index, but no changes. And that's why it becomes so much easier to adopt. And what we have seen is, and this is an unbelievable number, some queries are running 300 times faster. I'm not saying every query, some queries. Some queries run 2 times faster, some queries are 10 times faster. So on average, what we are seeing is 10x, in some cases even larger. I'm going to show you some examples from our customers, which is even 100x. So that kind of a performance gain, and the funny part is no change to the application. So that is one part. And remember, we were saying compression. So now if I want to show you the space used, right? Space used. So these are the two tables, right? One with column store, one without column store. The top one is without column store, right? That's row store. And what you see here is that the size taken by this row store is around 2.5 gigabyte. And here it is, 700 megabytes. So it's like 3 to 4 times the space savings. And again, this is a generated data, so it does not compress as well. But many production workloads, we are seeing approximately 10x or more data compression. So what you are getting here is reduction of your storage 10 times, and the speed of query performance 10x, 40x, 30x, whatever it is, big way. So you win on the both sides. You're not only reducing your storage, you're improving your query performance big way, and without changing the application. So this indeed is the power of column store index. So on that note, let me go to the presentation. So this is the value proposition. Now, if I want to show you the numbers, this is the TPCH benchmark, the benchmark that is done by the ANSI standard. A lot of our hardware partners, when they came out with a new hardware, they want to showcase the meanest workload they can run and say, what performance and they can get. Now, notice something. This is 10 terabyte of data warehouse workload, 10 terabytes, right? Very common. I have not seen many data warehouses above 10 terabyte, not that they are not there. On 10 terabyte, SQL Server holds the world record on the last 7 numbers. See, SQL 16, SQL 16, and so on. Right? So we are at that level, the market leader at data warehouse on a SMP box. I'm not talking about scale out model, SMP box. And then if you look at the bottom number, which is 30 terabyte, again we are the leader with 2016. So this technology that we got is a industry leading technology. Now you can say column store is a column store, right? But actually, if you think about, Oracle has a column store, HANA has a column store, DB2 has a column store, and it's just that the implementation of those column store are different with different organizations. And we have, clearly our implementation is superior. And one key reason of that superior implementation is something called batch mode execution. And I will not go into the batch mode here, but I think we have done some pretty fundamental improvements to column store implementation that helps us lead the world market with these phenomenal numbers. So that's where we are with the TPCH workload with column store. Now, I was telling you about a lot of improvements that we have done with column store. So we did improvements both in the performance side as well as functionality side. So on the performance side, what we have done is we do a string predicate push down to the scan node. What it means is the reason I want to call out string predicate, because in a traditional way, what you used to do, what SQL Server used to do, it will get the row out of the scan node into a filter node, which is where you apply the predicate, and it will apply the string predicate. String comparison is expensive, as you know, and then if the row qualifies, it goes up, right? So what we are doing with 2016, instead of applying the string predicate at the filter node, we push the string predicate to the scan node. And by doing that, we are It depends on the data, but we see a significant improvement in the query performance. And the magic is this. If you know about column store, the column store strings, it is stored in a dictionary. So when we do the string comparison, we compare the dictionary entry rather than the actual row entry, right? And if the string is repeated 10 times, right, you only compare once versus 10 times, right? So that is the kind of gain we get. Aggregate push down, same kind of things. Again, these things happen behind the scene. You don't have to worry about if you were moving from 2014 to 2016, this happens automatically. You don't have to worry about it. Aggregate push down, new batch mode operators. Sort is a new batch mode operator. We have done window aggregates as a new batch mode operator. And then we have done the SIMD, which is a single instruction, multiple data. So basically same instruction cycle, you can execute multiple instructions. So all those things are inbuilt with 2016 to give you amazing performance. In terms of functionality, what we have done is we allow a non-cluster. So there, I'm going to go slow on this one. We allow non-cluster index on a clustered column store index. Okay. Now, it may sound mouthful, but think of this way. You have your traditional, like you have row store table, right? You have row store table on which you have cluster index, and then you have multiple non-cluster indexes. Before 2016, if you created a clustered column store index, we did not allow you to create a non-cluster index on it. Now, you can say, what's a big deal? In many workloads, yes, there's no big deal because many queries are running data across millions of rows. You don't use non-cluster index to scan millions of rows, right? You will be dead. So it works fine. But what actually is interesting is that many workloads, sometimes, it's not a pure data warehouse workload. Sometimes they need to do quality search. They have to do short range queries. And without a non-cluster index, it would have been impossible to run that query efficiently. With non-cluster index, you can even do primary key, foreign key constraints on a cluster column store index, right? Which was not possible before, right? So that we allow. So this is actually a huge improvement for us. And because we have this non-clustered index, we can leverage the index as a scan path to enforce row level locking. Previously, it was not possible. The locking was at a much higher granularity, which we call row group granularity. I can't say that word. Row group granularity, okay? It was at a much higher level. Think of like a row lock versus page lock. In the context of column store, there are rows and there are row groups. There are no pages per se, okay? So we were taking a lock at the row group level, which was a million rows together. So you can think of that. That's a very coarse level of lock. So this NCI allows us to do that. And the third, this is like a non-obvious thing to a lot of people. Always on, we have readable secondary. This is something we came out in 2012. The cluster index, column store cluster index, cluster column store index, if you had on a table, you could not run a query on it on the secondary replica. With 2016, we removed that restriction. And the reason we were able to do that was, I don't know how many of you know about readable secondary, but the queries that are run on the readable secondary are run under snapshot isolation. And since snapshot isolation was not supported until 2016 on column store index, we could not do that. And now, because we support it, we can do it. So that's what we have done.
There's a question from Anna. Anna asks, it looked like on that slide, no, it's this one, that seems like a lot of it's moving towards OLTP support for column store indexes. Is that true?
Anna, this is a great question. So we believe, right, what is a data warehouse workload? Data warehouse workload is insert and queries, right? Because you insert the data on a nightly basis or hourly basis, and then you do the query. That is a traditional data warehouse workload. But what we find is there are workloads, which you can say OLTP workloads, which are predominantly insert only and queries, of course, but they do 5%, 10% updates. Now those updates, were quite expensive if we did not have a NCI, because you did not know how to get to the row that you want to update. You don't want to do the whole the table scan, right?
Mm-hmm.
So yes, what we are recommending that CCI, the cluster column store index, could be used for OLTP workloads which are not as heavy for updates.
Gotcha.
Yeah. Then we came out with a third thing which we call real-time operational analytics. And what exactly it is? Think of this as what people do traditionally today. They run a transactional workload in their OLTP system, right? Like order entry system. And on a nightly basis, they do a ETL from the operational system into a data warehouse to run the queries. Now, the reason it is done because the analytic queries are expensive, right? You don't want to run those queries on your transactional workload. Otherwise, your transactional workload will slow down because of locking, blocking, and whatever not, right? So people have traditionally segregated transactional workload and the analytics workload. Now, think of this, the column store index can run the query much, much, much faster, right?
Mm-hmm.
So there are a category of those workloads where you can in fact run the analytics on top of transactional workload. That means for those you do not have to move data through ETL to a separate data warehouse. So what we came out with was updatable non-clustered column store index. And the reason we say it is updatable because non-clustered column store index was available in SQL Server 2012, but it was not updatable. Now imagine if you create a non-updatable index on a transactional workload, you'll be dead, right?
Mm-hmm.
Nothing can be inserted. So it was not useful, but now we have it. And I have actually an example, two examples where customers have used NCCI on their transactional system to get rid of ETL, get rid of data warehouse. So it's a very powerful thing. And finally, one thing which I wanted to point out is the column store index creation or rebuild is offline operation. In fact, we fixed the non-cluster part in 2017, SQL Server 2017, but it is a offline operation. And you can think of, right, if I have billion rows in my fact table, rebuilding that index could be expensive. And the reason you rebuild index is because index can get fragmented. Now, what we are providing with 2016 is you can defragment column store index online.
Mm-hmm.
Now, what does it mean, a column store index being fragmented? It is quite different than your traditional row store index. In the lingo of column store, index is fragmented if it has a lot of deleted rows. Because in column store, when you compress the data, you can't really remove a row. Because imagine this, right? You have compressed data, and somebody comes and says, I want to delete this row number 1000 from this compressed portion. You have to decompress, remove that thing, and recompress, right? It's a very expensive operation. So what we do is we just mark the row as deleted. And when you do the query, we just subtract that row from the result set.
Mm-hmm.
Over time, you can imagine that there are a lot of deleted rows. Those are dead rows because they are taking storage on disk, they're taking memory, and they're adding to the filtering overhead, right? So we actually provide a automatic way to defragment the data. So that can happen. I should take the point automatic back because we took it back. We need to run alter index rebuild, yeah, something like that.
Mm-hmm.
So that will take care of that. So this is at a very, very high level, the features that we have added to 2016. Now, I told you about the performance. So here is a very interesting chart. The TPCH number that we have, what we did was we ran the same workload, TPCH, on the same physical hardware. Notice this hardware here, same hardware, no changes to the workload, and we got 40% better performance, right? That means you upgrade from 14 to 16, you get such a good performance. And why this magic is happening? Because of a string predicate push down, NCIs, aggregate push down, many, many things, right? So this is what we have been telling customers that number one, if you were running on 2014 and you were happy, you will be happier when you go to 16 because on the same hardware. I mean, you get 40% better performance. I mean, nobody will complain about that, right? That kind of stuff.
Nice. Very
Yeah.
nice.
Okay, so this is actually at a very high level what we have done for Columnstore. Now, let me go through these 4 workloads that I've chosen for you guys. Hopefully, they will be compelling enough for you to think about Columnstore. So the first one that I chose is a traditional data warehouse where you can close your eyes, you can say I want to use Columnstore, and nobody will complain. So this is that workload. Okay. So in this case, it's a health insurance company in UAE. It's called Damon, and they have a traditional data warehouse with 100 target tables, and they get data from multiple places, and these tables have billions of rows, right? Very, very large database system. And it is, like in Kimball architecture, you have the star schemas, but in a organically grown data warehouse, the schemas become very mumble jumble, right? But it is, you can say it is like a star schema and
with a lot of stuff.
complex schema, with a lot of stuff, right? And you can imagine the tables, multiple joins. And this company, Damon, was running their data warehouse until last year on Sybase 16.1. They were running on Sybase. And I would say they had done a lot of engineering. They installed Sybase 3-4 years before that, and they were getting good numbers, but they had to put a lot of time to tune those queries. So so this is how their data warehouse looks like. They have this. I mean, I won't even guess what these are, but pretty much data is coming from multiple sources, right? It's going through whatever ETL chain. It lands into this database, right? And this is where you are reporting queries, and these are the users. So the focus of this application migration was this guy. The UDM was running using Sybase, as I said, year before. And this is the query. They have claims and the members and whatever not. And these are big tables, and you can say these are the dimension tables. So here you can say that each query, typical query, involves 3 or 4 joins, right? This is a typical query. And this is a more complex query. This is what I was talking about. It is just, organically grown schema. I mean, it gets complicated. So this is the kind of queries. And what this customer found was their data was growing and the queries were running slower and slower and slower. And they just did not know how to tune it. So they contacted this company. I think it's called, I'm forgetting now. They called it a consulting company, and they asked them to help them design their system for the next 5 years because Sybase was not scaling for them. And their requirement was, I want better performance because if the performance is good, I can do more queries. Because, imagine this, if you run the query, it takes 5 minutes, chances are you will not be as agile in your analytics, right? You will say, well, this is good enough. But if I get you the result in like 10 seconds, you may be tempted.
Yeah, you ask a lot more questions.
Yeah, you'll ask more questions, right? So they believe that, the more insight, the more impact to the business. And they wanted the response time in seconds for common queries. Remember, I was talking about common queries on the right top. And the bottom one is more like a reporting queries that they run every night. So seconds response time. And I think their challenge, as I was saying, was they could not scale the technology for the volume of data they were expecting from now till the next 5 years. So what they did was they hired this company, and they actually, as it shows, they had 6 contenders. Okay, and they had in fact Oracle. They had Oracles and other big vendors they can think of. They were there in the run. And around beginning of 2016, they contacted us, and we worked with them very closely to give 2016. They were also trying 2014 because it was in production and it was within the time frame, so they were not thinking of 2016. but somehow we contacted them, or they contacted us, and they said, okay, we'll do a POC with 2016. And between March and June, they did the POC, and in June or July, they went in production because the numbers were so good. I'm going to show you the numbers. Okay, so this is a solution they came out with. They had the fact table, right? They had multiple fact tables. They use CCI, stands for Clustered Column Store Index. And they also needed to create a non-cluster index on top of it because some queries could benefit with a non-cluster index. Okay, and even the dimension tables, some of them were so big, they used they used clustered column store index. And the rule of thumb for the column store index is the number of rows should be at least 1,000,000 rows, because when we compress in a unit of million rows, right? If you have 100,000 rows, it makes no sense to compress those rows because it's not big enough, right? So anyway, so they did that. And this is the most interesting slide that I want to talk about. So they did, remember they had like 5 or 6 contenders, and so they ran those queries. The left thing that you see here, this is at the bottom says 2.8 minutes. These are the reporting queries that are more complex. And on the right side, it is 1.1 second or 25 seconds. These are the typical user queries that they wanted to run in seconds, okay? Now, the thing I want to point out on the left picture is that SQL 14 is this blue guy. It was running that query in 26 minutes, okay? This is not seconds, this is 26 minutes, right? Because they were very complex queries, billions of rows. In 2016, no changes, ran the same thing under 2.8 minutes. Okay, so SQL Server 16 gave them a performance gain of almost 10x. Now, this competitor, I can't tell the name because legally we cannot. This competitor was running at 3.2 minutes. So imagine this, when they were evaluating 2014, this competitor came out good here and not here, right? Not here. So they were in this fix. What do I do? What do I do, right? Then 2016 came, and notice it is leading the pack. 2.8 minutes for very complex queries, and 1.1 second for the typical user query for which they wanted to get the query performance in seconds. So based on these numbers, they just decided that 2016 is the right product for them, and they migrated the load to 2016. And I would say this, they are primarily a Oracle Sybase shop, and they were so impressed with this number, they are in fact looking at other applications in their organization which they can move to SQL Server 16. So that has been the power of this technology.
Nice. And I'm guessing it's probably saved them a ton of money because they probably didn't have to rewrite a lot of queries either. I mean, if they're coming from Sybase.
That's right. Yeah. So Sybase is a cousin brother for SQL Server, right? Yeah, exactly. And so this is what it is. And when they ran the number, so this was a POC. Okay, this was POC. Then they ran the numbers in the production now, right? So ad hoc queries, you can see that they don't have the numbers for this daily runs, okay? But they have numbers like weekly reports, 60% improvement. Like notice, the SQL 16, it takes 10 hours to do the report. Sybase IQ, 28 hours. Business monthly thing, 10 hours here and 2 days in Sybase, right?
Yeah.
So you will only run on a weekend.
Nice.
So this is a huge amount of gain. And again, the thing, as I showed you in my simple demo that I had, all they did was, change the query, change the table to use cluster column store index rather than a row store. Now so I actually so what happened was this person was here in Redmond to give us a live demo of their queries. So this is a typical query that they had, okay? Notice it has a join on 3 or 4 tables, this alert table, which was a fact table, 2.75 billion rows, right? And they ran the query live, and I think I want to show you, I can show you that it ran in 3 seconds at the bottom. Just trust me, it ran in 3 seconds. And they couldn't believe it, that this can run. So this is the numbers they showed in the production system. So I just wanted to capture the screenshot because I cannot show the demo myself.
Of course,
So,
yeah.
so that's the power. And learnings for us was, as you can imagine, they would do a lot of, like, this is the insurance company, right? So you file a claim and there could be some change. You need to update those rows, and updates are done as delete inserts. So what we did was, when they were having this nightly changes, we did some tricks about how do you handle that kind of thing. So what we did was, we did delete in first pass and insert in the second pass, because updates are delete insert. Because if you do updates row by row, it was more expensive. So we did some tricks like that, and it worked out well for them. And in the optimizer, and this is, I think, Brent, you might have seen as well, our old cardinality estimator is giving better query plans for many workloads. And so what they did was, they used the old cardinality estimator with SQL 16 to get these numbers.
Okay.
And I want to show, this is a case study. This is live. You can check it out. And these are their vice president, or in this case, architect, said they got dramatic improvement in the performance over Sybase, right? This is one example they quoted. And instant answer to their queries. Remember, it was 1.1 second in the POC. So they actually are able to use this performance to their advantage to increase the impact of their business. So this is a very, very actually good case study for us, because not only it showed what Columnstore can do for a real workload, it also helped us compare Columnstore with the competition. So that was one example. Now, any questions, Brent, on this side, or I go to the next example?
No, well, there was one. Joe says, do you expect 2016 SP1 to improve these benchmark numbers even further? Because he's seen, I'm sure, like Pedro Lopez talk a lot about the improvements in SP1,
That's
for
right.
example.
Yeah, right. So, no, what we have not done any improvement on Columnstore that I recall right now. Lot of our improvement that we have done, that Pedro talked about, was on supportability, like making the query plans much richer in terms of diagnostics information or the clone database or stuff like that, but not for Columnstore per se. A lot of performance improvement that we are doing will come in 2017. And the question gets asked is, would you backport those enhancements to 16 or 14? Chances are low, because in many cases they require a lot of changes to the code, and bringing the code to previous release is risky. And also we want people to move to the newer version of the release, right?
Cool.
Okay, all right. So this was one scenario where, this customer, the story is this. They were working on this problem, which I'm going to describe to you, with Microsoft. They tried different technologies, and I don't know how, but we got contacted. They said, okay, see if Columnstore can help. So they reached out to us. Okay, and I looked at the workload, and I'm going to show you what the workload is. It was not obvious to me that Columnstore will be helpful, and I'm going to show you here. So what first American title company, I mean, most of us, or some of us, have dealt with real estate at least once in our lifetime. You have to fill a title, right? Get a title of the property. So this is that business, and what they do is they provide this service to the realtors in US. So what they have a database of 150 million properties in USA. Okay, and it is coincidental that they have 150 attributes of each of those properties. So 150 million properties and 150 columns. So columns could be, the price of the house, square footage, year it was sold, number of bedrooms, stuff like that, right? So those are the properties. And then, if you want to search for a house, you will search, I want to search in this geographic region, this kind of accommodation, price, whatever not, right? So people will run those kind of queries. You are not looking at aggregates. You're saying, show me the properties that meet my criteria, right? So there is no aggregation, right? Now, in many cases, people are interested in, year it was sold, what is the tax? I mean, like on average, they were running with 10 plus columns in terms of attributes they want to see of a given property. and the results was returning approximately 100 rows or more. Okay, so this is what it is. Now, when you think about a data warehouse, this does not look like a data warehouse, right? Because you're not doing any aggregates, you are just doing selections with predicates, right? Now, other thing was their daily ETL was 1 million rows. Now, you would wonder what is changing in the property, right? Why it is changing? Well, think about this. Yearly, the tax is increasing. If you have 150 million properties, there are 150 million updates at least per year, right? And then people are, improving their property and like adding a room or whatever it is, right? So on average, they were doing a ETL, which is 1 million rows. ETL, most of them were updates. They were not new properties. Of course, new properties were there, but most of them were updates. And as you can imagine, updates are expensive. So we were not thinking of column store. So this is what they did. They said, well, this is not a column store scenario. And what they did was they said, what are the common queries people do? What is the common queries people do? Okay, top people are looking for queries on these 20 properties, like 20 attributes of the properties, like number of the square footage. Let's do this. Let's create an index on each of those properties. And when I run the query, if it is matching those properties, I will be able to run those queries faster, which I think is true. But if somebody comes from the left field and uses properties that nobody queries too much on, those queries will run slow because that will mean I have to scan the full table scan 150 million rows, right? Okay. Clearly, they could create index on each of those attributes, but that will be suicide because if you create 150 indexes, ETL will, who knows what will happen, right? So that was a choice. So that was the problem they had. And what happened when they contacted us, they were working with moving this solution. They were running actually this solution on SQL Server 2014, believe me, 2014, and they were not using Columnstore because they did not think it was Columnstore useful here, right? And they were also saying, well, this is not working for us. Let's move to a competitive platform which has whatever not, right? So somehow we got involved, and their success criteria was that 95% queries should take less than 5 seconds, which makes sense, right? I mean, you are searching for a property. If it is going to take you 20 minutes to get back what it is, you will not, you forget about it, right? So, okay. No query should take more than 10 seconds, and they should support up to 400 concurrent users, at least for now. So this was a slow example of slow SQL that, you select list, you search for a property where you can say home equity percentage 50, whatever it is, right? Mortgage this, mortgage that. And it was taking 8 minutes to run on their system with SQL Server 2014, all right? This is another example where, some other thing, maybe here there was an index available and the query ran in 10 seconds. So you can see the numbers they were getting were way, way slower than what their success criteria was. Okay, this is what they were, right? So we reached out to them, and what happened was they had this traditional row store, right? Here you can see the yellow guy is a row store, relational table, disk-based, cluster index. They had a B-tree indexes on it. They had a full text index on top of it because they were searching, where, you see what I'm saying? I mean, like, something like that. They also had a spatial index. Why? Because they were also saying, I want to find a property, and they had a graphical interface. You can say you draw a circle in this area, right? So they had a spatial index. So this was actually the solution they had for SQL Server 2014, which they were in production with that, right? So what we did was we asked them to create, guess what? A non-clustered column store index, NCCI. Okay, and what actually Anna was asking about OLTP workload. So OLTP workload operational analytics can be achieved through NCCI. So we created NCCI. So what it means is everything that was working before works like before because we did not remove these structures. Now any query that requires a column store will automatically run here much more efficiently. This is what they did. No changes to the application. Now, clearly, in this case, we did not support a spatial columns in non-cluster column store index, so we removed those. And so how did the magic happen? Why did the queries ran so fast? I'm going to show you the numbers. So this is where some background in column store is useful. So in column store, imagine here we have 150 million rows, right? So what we do when we create a column store index, in this case NCCI, we group the rows in units of 1 million rows. This is the goal, not every time we can get that unit. So let's assume we had 150 units, right? 150 million rows, 150 units. Now for each attribute of the property, except for strings, we had the min value and the max value. This is a common metadata that we have for column store. So we had a min value and a max value. So now what happens when people put searches on the property to say, you know, where the bedroom size is, bedroom is 3 square feet, so and so, we were able to look at that metadata that we kept with each of those 150 units, and we were able to eliminate a lot of them. And we then have to search a very few number of rows for the qualifying properties, right? So that means we did not have to create indexes, non-cluster indexes, to speed up those searches, because column store maintained that kind of information automatically. So which means they removed a lot of the B3 indexes they had for query performance, and in fact that ETL performance improved, because, you know, as you can imagine, more B3 indexes, the harder it is to do ETL, right? Okay, so this is what they did, right? But they did not want to go to 2016 because 2016 was not out there, and First American had this policy that they will not go to the new release of SQL Server until SP1, right? So you heard about that, right? I mean, a lot of customers, yeah, okay. By the way, that has changed in a very dramatic way because of cloud offering, but anyway, so they had this corporate policy, and so we said, okay, we need to do this thing on 2014. But 2014 did not have a NCCI, so what do we do? And so this is what I actually wanted to impress upon audience here is you have to think about solutions a little bit out of the box. So what we did was we said, and so what for in their case, the storage was not an issue for them. So what we did was essentially we created 2 row sets, right? One was cluster column store index on the left side, and one was whatever they had before, right? Okay, now they put a layer, of course, in between, which will figure out the query should go to column store or to the row store.
Whoa.
Right? Okay, and this is exactly what they did. And I asked them how expensive it was for them to do this, and they said literally 3 weeks, and they were able to do this because this was there already, right? And this data was just a, you know, select star, insert into column store, you're done, right? And this is where the logic was put, and I'm going to show you an example how they did it. And this is how it looks like. Okay. For example, if I'm searching for a property select list, and this is Normandy, whatever the database was called, some property where property ID is in this, and here you have like city like this and the bedroom like this, right? So what they did was this part was executed inside the column store, and this was on the row store. So that's how they did it. And the numbers are insane. Okay. So imagine this. What they did was, I'm going to go back to this slide. They did the nested query that I was showing you here, and they got the property IDs, and then they fed that into this guy, and they got the results back, right? Okay. So the row store, which they were using before we moved to column store, it was page compressed. It was 560 gigabyte. And with CCI, it became 44 gigabyte. Now, they moved to a solution with 2014. So now their storage is actually 560 plus 44. You agree? Because they have CCI as well as row store.
Conventional stuff, yeah.
Yeah, because they have to duplicate. But when they move to NCCI case, the total storage will increase only by 44 gigabyte, right? Because NCCI will be of the same size as CCI. Yeah.
It's affordable. Yeah, it's cheap.
It's very affordable. Storage was not the issue for them.
Yeah.
And the CPU consumption in their query went down from 23% to 7%, right? Because column store execution is much, much faster. So you will say 23% was not a big deal, which is true, but this is average. They had peaks and valleys, right? I mean, when the fall begins or the summer begins, people are doing a lot more property buying and selling, right? The peaks of the workload was high, so they had provisioned for the max. Now, this is, of course, a very good example for them to move to Azure, where you don't worry about the max, right? But of course, if they have a policy of going to SQL Server with SP1, they will not go to cloud right away because cloud is changing every day, right?
That's true.
So anyway, so this is one example where cloud could be extremely helpful. So this is all good, right? CPU, but here's a phenomenal thing. The query performance on average, okay, from 2 minutes to 2 seconds. That is 60 times faster. So they were so happy with this. I mean, they are in production, and of course you can imagine it created a wave in their organization to see what else can we do with SQL Server and workloads which can leverage this kind of technology. So one example that one point I want to make here is that this problem that we were solving did not look like a column store problem, but it worked out well in this case. And you can see how we improvise the solution of creating 2 copies of the data to get around NCCI, stuff like that, right? So very, very successful for us.
While you're on there, there's a good question from Ratan. Ratan asks, seeing that there's 2 different copies of the table, he said, makes me think of, do you recommend different storage configuration for column store tables versus row store tables? Like, should you put them on faster or slower SANs? And he has a follow-up question too.
Right. So I think I would say this, right? If you look at the total size of column store is 44 gigabytes, right? If you're running this application on a 256 gigabyte machine, chances are your column store will be all in memory, right? It's not going to take a whole lot of memory. So, I would say this, that if your working set can fit in memory with column store, then you don't have to worry about storage aspect as much. Of course, ETL or loading data will be whatever it is. So we have not seen a significant guideline on that this should be on this storage or this should be on this storage. Having said that, if you have a partition column store index table, of course, older partitions you want to put on a storage store device, right? That's a typical partitioning thing. So in this example, they did not put column store on a different storage. In fact, it was on the same storage.
And he also asks, is there different maintenance between column store indexes versus regular indexes?
Absolutely.
I know we touched on it a little, but
so let me describe to that. I think that's a very important point. So let's look into what is a fragmentation. Why do we do index maintenance, right? So what happens is, if you have a B-tree index where data is stored in a ordered way, and if I insert rows in between, the pages will get split, and then the new page will get allocated from the end, so the database or the index gets very fragmented. That means the range queries will run slow because I have to run around the whole disk to figure out where the pages are, right? So we, of course, in the B-tree indexes, we want them to be physically contiguous, right? The range should be physically contiguous for the best performance. So there's a fragmentation. This has been there since Sybase days, and you run defragmentation. Now, in the column store, the difference is, I'm going to go back to the picture, Brent, if you allow me. I want to go to this picture, okay? Okay. Here, this is the column store. These red guys are read-only guys. So when you do delete or updates, these guys don't change, right? They are physically contiguous or whatever it is, right? They are just sitting there like that. The fragmentation in column store is the deleted rows, right? So if I delete rows, I have to create another structure on the side, which I have not shown here, which is tracking the rows that were deleted, right? When I update a row, I delete, same structure, and the insert happens into it, right? The question would be that, hey, how can you insert into a compressed store? We do not. Of course, we create, it's a very complex data structure if you think about. We have a row store hidden inside the column store index. That row store is landing zone for the new rows that are coming in. And once that landing zone becomes million rows, we try to compress them, right? Okay. So what happens over time, like I was updating, doing ETL million rows per day. So, and you can think of this way, I'm going to, another example, right? After 1 year, right? Let's say tax on all properties change. That means I have to update all my rows, right? That means all the red guys that you see here will be marked deleted, right? Because everything has been deleted. So it'll be fully fragmented. So what we do is we track how many rows are deleted on a given unit of million rows, right? We track that information. And when you run the reorganize command, we have some sort of policy-based defragmentation. And what it does is it removes the rows that are deleted and recompresses. So for example, if you have two of these guys, vertical guys, this is a row store, million rows here and million rows here. If I have, let's say in a simplistic way, 500,000 rows deleted from the first one and 500 from the second one, when I do defragmentation, I'm going to combine them into one. And I'm going to throw away the deleted rows away, right? We can combine up to, I think, up to 10 of these guys, right? So by doing that, essentially you are removing the deleted rows, and that is the defragmentation of the column store. So it is quite different than what you have for the row store.
Oh, so it's not just making each individual row group smaller. It'll also combine row groups.
Combines them as well.
Cool.
So here's the interesting point. I think since you mentioned, so we have this rule of 10%. So if I have million rows, and if I delete more than 10% rows, that means 100,000 rows, only then I will remove those rows. So I'll take those that row group, I'm going to compress it back to 900,000 rows, right? And if I can combine with something else, I'll combine. But the goal is the row group cannot exceed million active rows.
Then Damien asks one, going back forward a couple of slides, he says, when this company says that they sent some of the queries to the row store table and right there, yeah, some of the data queries to row store and some to column store, was it just a matter of rewriting these queries so that it has like the subquery approach, or did they actually have an intercept layer in the app that would send different queries in different places?
I actually don't know, because they were very confidential about how they were doing there. They just sent us this example.
Okay. All right, cool.
Yeah, but I think think of this way, right? They have to intercept. I mean, the query, the interface, the web page, which was form based, right? You essentially say bedroom size so and so. It basically comes into some app tier layer, and then they are generating SQL queries. So it has to be done at that level, but it was not very complex because they were able to do that with one person in 3 weeks.
Okay.
Yep. Anything else?
Nope, that's all of them so far.
Right. So far, so good. I mean, you guys are liking it?
Yeah, they seem to be paying attention.
Okay. So the next thing that I want to show you was a very interesting application, okay? And this is a hybrid application, hybrid in the sense they had both transactional workload and the analytic workload, all right? So there is a company called FIS, I forget the full name, it's financial something. And so they actually, what they have is I'm not an expert in this security market, so I'm going to hand wave here. Basically, they have these traders who are making trades, and they also not need to see the trend. I mean, if I bought Microsoft share, 1,000 shares or 10,000 shares, how the securities are trending in real time. And based on that, I can, make some day trading or hour trading, whatever it is, I make some decisions. So from my perspective, whatever he explained to me, it was clear they have transactional workload where they are buying securities or selling securities. And also they wanted to do analytics on those things that are they are doing as well as being done in the market, right? And the way they were doing this was they were moving the trades every 5 minutes. So they're running ETL program every 5 minutes into a data warehouse. And the traders, when they were making the trade, they were making the trades in real time, but the trends they were seeing were 5 minutes older, right? Now, according to them, each minute can make a difference of huge amount of money.
Sure.
They wanted to have this analytics to be done in real time, right? That means zero ETL time. And the only way that is possible is if you run analytics directly on the transactional tables. Now, before column store, that was not really possible because queries will run slower, they will mess up the transactional workload and so on, right? So that was not an option. But so they were actually in a very hard and rock place. They said, well, we can't mess up the transactional system, but our traders want real-time analytics. What do we do? So that was a problem. And I think this is an important point because HANA, if you know about, HANA actually was the first, I wouldn't say first, but first big one that allowed customers to run OLTP workload and analytics on the same tables. Okay, that's what HANA's big deal is. If you know about Oracle 12c, they came out with an in-memory option. Some of you may have heard about it. What it is they are creating a non-clustered column store index on transactional tables, and they maintain that index in memory, stuff like that, right? So every vendor actually is recognizing that there are scenarios where analytics cannot be, there cannot be any latency in the analytics. They want to do analytics in real time, okay? So that was their problem. So as I was telling you about, right, they run this 2012, they were running on 2012, row store, transactional processing, ETL every 5 minutes. And the funny part was, and this is something I don't fully understand, their transactional volume was 1.2 million rows per 8 hours of trading. That volume looks low, so they were not really trading Microsoft shares, they were trading something else, but the point was they were 1.2 billion rows per day, right? So that was the extent of their transactional workload, 1.2 million rows, and every day it becomes like zero and then start again. So the question really was, if you have 1.2 million rows, the column store index will not really help you, right? Because if you create a column store index on the table, at least for the first 6-7 hours, the rows are less than million rows, right? They will not be compressed. So you will not get any benefit from column store. So this clearly did not meet our criteria, right? And again, this is what I'm saying, think outside the box. So what we did was, so I told you about the challenge. This was a challenge. They wanted to do analytics in real time. So no column store benefit, 1.2 million rows starting from zero every day. And so what do we do? Right, that's our question. And so first thing we said, let's not worry about 1.2 million rows getting compressed only towards the end. Let's compress the rows and see if that meets the requirement of your dashboard. What they had was a dashboard where you see all these trends. They had 8 forms, 8, I would say, what is that called? I don't know what the term is that, you have a web page and you have 8,
like portal parts or graphs or
yeah, they had 8 portal parts, and for each portal part they were querying the SQL Server to fill in the information there, right? So they had 8 or 10 queries they were running, and that thing has to be refreshed under 3 seconds. That was their goal, that I should be able, if I go and say I need to have all 8 queries run under 3 seconds. So what we did was we said, well, we will try non-cluster column store index, even though we know 1.2 million rows over a course of 8 hours does not make sense for column store, but we'll try that. And also we will try in-memory OLTP, which is Hackathon, with column store index. So those were the 2 solutions that came to our mind, and we said, let's do the testing. So first thing what we did was we said, well, let's take the best case, right? Because if everything was compressed, you run your report or the dashboard, and if the dashboard can be rendered under 3 seconds, then at least this technology has legs to run on. Otherwise, it's not even a solution for you, right? So they compress everything, right? And they ran their, the dashboard, and everything was running fine. So it was very clear to us that only if column store was compressed from row 1 onwards, which is not possible, then their solution would be cool, right? We could do that. So here's what we did. We created an NCCI on the column, on those row store tables, right? That was not a no-brainer. You have to create NCCI because transactional workload has to run. You have to run analytics. What we did was we forced compression every 100,000 rows. Manually, we said every 100,000 rows. So that means every 45 minutes, just run the force compression. And what is the force compression command? Actually, it is a reorganize command with the force option. This was available. This is available in 2016. It was undocumented in 2014, but it is available as documented. So all you do is alter index, the non-cluster columns or index. I forget the syntax, but reorganize,
Sure.
right?
Yeah.
With force option. So what happened was every 100,000 rows, it was getting compressed. So instead of getting 2 row groups, right? I was saying each row group is of size 1 million, right? Instead of getting at most 2, we were getting 10 because we were compressing every 100,000. Actually, we are getting 12, right? Because every 100,000 rows. And so that's what we did. Okay. And what we found was that the performance was still within their SLA. Because clearly 100,000 rows were not compressed, right? If 100,000 rows I compress, then the next 100,000 rows are not compressed, right? Those will be slower. First will be faster, right? So the performance will not be as good as it was when everything was compressed, right? And this is the number they got. So on the thing that you see on the highlighted is the improvement with column store NCCI. This is the performance with the row store, and this is the performance with the NCCI,
Non-clustered.
non-clustered column store index. And you can see it has improved in a pretty dramatic way, depending on 12x, 18x, whatever not. And the queries that I'm showing you on the left side are those queries, I think Brent used the right term, filling those forms or filling those
Portal
portions.
parts.
Yeah, portal parts. And in the number that you see on the right side, this is the graphical representation. The green below is with NCCI, and you can see the fluctuations, right? Because when the data gets compressed, it runs faster. When the data is not compressed, you know what I'm saying? It will slow down. Yeah. Okay.
And at only 41 batch requests a second, I mean, you can afford to rebuild it in the middle of whenever. Yeah.
Which one?
If you're only getting, it looks like on average they're getting 41 queries per second if you divide out 1.2 million a day.
Right.
Yeah.
Okay.
Safe.
And so they are live in production, and this is the case study they have. And I think I think your attendees will be able to download the deck, right? I'm going to send it to you.
Yeah.
And this is what their vice president, Aaron, actually, he was one of the persons whom I work very closely with. He is the only vice president I know who is as technical. I mean,
questions.
He was very technical. Yeah, very deeply technical. And in fact, the funny part he says was he didn't have to involve our DBAs. And I said, that is insane. I will not create an index without a DBA knowing about it. But he said he didn't have to involve DBAs, but that's what vice presidents can do. And
you don't usually want to see vice presidents adding indexes, but yeah.
But anyway, so the thing was, they were able to run the queries that much faster and without changing anything. I mean, it was like, they were just impressed. In fact, Aaron will be presenting with us in Ignite conference in September about this this thing. So I think let me summarize this part. And I think my time is. I have another customer. Okay, I'm going to keep going. Yeah. So I think interesting thing about this one was, think of this, right? It was obvious that we should use non-cluster column store index because it was real-time analytics, right? You have transactional workload and you want to do analytics on top of it. But it did not make sense because number of rows were much, much lower. And we got around that issue by forcing compression every 100,000 rows, just have a batch job, agent job that is running every 45 minutes and compressing the rows, and it worked out well. So they were actually pretty excited, and they are live in production, and so yeah, it is very exciting. So the last one that I want to show you about is again real-time operational analytics. It's a company called M-Files. Okay, M-Files is a competition to SharePoint. And interesting thing is, I think I think the problem that I see with SharePoint, excuse me, let me just take a sip. Yeah, thank you. So problem I see with the SharePoint is, like, when you upload a file in a directory, it is very hard to see that file with a different property. For example, if I have, 3 departments, I have department 1 files, department 2 files. If I want to see all the files that have certain property, I mean, there's no easy way to find that in SharePoint. So what M-Files solved that problem, saying we will store the files in a very, in one place. However, what we will do, we will keep the metadata, which is the properties of those files, in SQL Server tables, and now we can show you the organization of files in any which way you want to see, and then you can just click on those properties and it will fetch the file from the file store. The files were not part of SQL Server. Okay.
Okay.
So here example, I'm showing you a proposal here, and they have these different properties with the red tags here, and these properties can show into some directory structure, like structure they show to the navigation bar to their application, and they can do whatever they want. Okay, so this is their application. So what they do is, let's say I want to upload this document, right? Like a SharePoint, I'm uploading this document. They have a lot of these properties. So what happens is when you insert a document, when you upload a document, they are inserting approximately 60 rows into different metadata tables that contain the properties of those tables. All right? Okay. Now, if I change a property of a document, I have to go around and change a lot of updates in those. Yeah, you see what I'm saying? So there's a lot of insert delete updates are going on. This is the transactional workload in those meta tables that's going on. And now, if you have that, you can see now you can render the structure of the documents. I'm showing in the left example like this, or by proposal by year and month. I mean, you see what I'm trying to say? I can see the same document in different ways and forms, right? This is what they had.
Business intelligence for documents, basically.
That's right. That's right. And this solution they actually implemented on SQL Server. I'm trying to remember, either 12 or 14, and they were fine. This is working fine for them. And what they found was that let me before I show that, what they found was as number of documents increased beyond 10 million documents and above, the metadata manipulation was much slower, and they could not meet their SLA. And their SLA was that insert, when I upload a document, it should complete within 1 second, that metadata update. And mass updated document, they had like a much larger changes to the document that should take 2 to 3 seconds. So basically I upload the document and everything should be done within 3 seconds for me. So those were the requirements. And the listings that they were doing, right? Listings actually were, I'm going to show you a query. There were no aggregates in those queries. They were saying, show me group by department, you know what I'm trying to say, those kind of properties, and I want to show that. So the rendering of the metadata they were showing was using analytics kind of queries. Okay. Now, they wanted to see those listings in real time, and what they were finding was as number of documents were increasing and increasing, they could not render those structures in real time. That was the problem. So if their customer was going to go beyond 10 million, they basically said create 2 stores and stuff like that. Those were like hacky workarounds, right? It doesn't work. Okay. So what do they do? So like this is the workaround they had, and they were saying their customers were thinking of 100 million objects in one vault, right? So the question really was, once you go beyond 10 million, they were slowing down, and their customers were expecting 100 million, say, in 3 years. So that was the problem they had. And in this scenario, they evaluated Hadoop, HP Vertica, NoSQL solutions. They did many things because they were in a fix. They said, how do I help my customers? And the challenge they found with these technologies was their non-existing support for ACID, right? I mean, they want to have, full atomic, consistency, whatever four properties that transactional system give you. They did not have those in a very strict way. And also they wanted solution that could be on-premise, because some customers of theirs were on-premise and some customers wanted them to provide as a service, right? So I just upload my document to your service and you manage everything. I'm just gonna, do my business. So they were looking for a vendor that could do both, and SQL Server or Microsoft, for that matter, actually had both of these things, right? So I remember they came to our lab in the summer of 2015, and we were working on NCCI. And so we said, this is because you're running analytics kind of queries, so NCCI has a good solution, transactional workload, because you're updating, deleting a lot of rows. So let's do that. And the beauty was, when you create a non-cluster columns or index, there's no application change, right? It's just an index. And another thing that is important is, right, a lot of times you have a transactional workload, but people have in that transactional workload some indexes created only for queries, right? Because you may want to queries, right? Now what happens is when you create an NCCI, some of those indexes may not be needed. In fact, we have one customer where they created an NCCI and they dropped 3 other indexes that were not needed anymore, right? So the overhead became even lower to maintain an index. So the point I'm making is just because you're adding an NCCI index does not mean you have one more index. It could be effectively you may be lower number of indexes. Okay. So anyway, so they created this index. This is how it looks like, right? In the top, you have these B3 indexes which they had for their application, right? And the metadata table, which is the metadata of the documents, and then we created this NCCI. Okay, and the results were phenomenal for them, and they had a environment with 77 million rows, right? And the total database tested was 5 terabytes without compression. And notice this database does not have
the files in it.
It does not have files in it. Yeah, and it is true that you create an NCCI, which is index plus one index, and maintaining NCCI is a lot more expensive than a traditional index. So the impact on the OLTP workload was less than 5%. That was one of the big concerns they had was if I create an NCCI, will my OLTP run? Yeah, how much slow? Because they still had this SLA of 1 or 3 seconds, right? Showing in the beginning. And this is the number they got. That after, so OLTP performance, 5% overhead was okay. And OLAP queries, which is rendering the directory structure, stuff like that with different properties. Red shows before and after is green is after. So from 6.5 seconds to 0.5 seconds, that is 13 times. And then 2.6 second to 0.05 seconds. So 0.05 second means 20 into, to 52 times, right? So they were able to get this kind of a gain without changing their application. So they were just, they were pretty excited. Hey, I could solve my problem without, and this is the kind of query they were running. This is like a query that runs over NCCI. So I don't want to understand what this thing is, but this is the generated query for, But you can see this is a mean query with like lots of joins. And there is no aggregate here. These are like top, show me, whatever it is, right?
Individual rows, yeah.
And this is what they said. This is their actually founder and CTO. He was here, and he said 10x faster. I highlighted a few key items, and I think the most exciting part for them was no changing of the application. So
I bet the storage overhead was pretty small too. If you're talking about,
exactly. Yeah. I think of this, right? If I assume 10x compression and you're not creating NCCI on every column, right? NCCI you will create on one column. Yeah, you're right. Actually, I don't know about how much storage overhead they had, but I should find out. But yeah, you're right.
It's got to be low. Yeah.
Yeah. So this pretty much are the 4 customers that I want to talk through. Just want to summarize for you is a traditional data warehouse where they just move from row store to column store index. And the number they got were much, much superior compared to SQL Server 2014. We understand somewhat why, and also against all our competition. So again, of course, not every workload will be best for columns for SQL Server, but what I'm saying is this was one good production quality workload, not a benchmark, where we could show that we beat the competition hands down. Second example that I showed about the title company, where it didn't look like a traditional data warehouse. Columnstore was able to solve their problems. Third one was that 1.2 million rows, which did not fit the Columnstore model, but we made it work. And this one, the real-time analytics. So, and I think there are many more customers. We have, I don't recall how many that we are working directly with, but there are many customers I see through the post and everything. They move to Columnstore Index and they are just happy. So I hope this sort of gave you some idea about how Columnstore technology can be deployed in real workloads and playing some tricks and make your customer successful. Brent, that's all I had. Thank you so much for your time.
Very nice.
I'll be happy to answer.
Yeah, very nice. There's several people that asked or had said they were really impressed by the unusual solutions along the way. Joe asks, In the example of, and I forget which example he was looking at. It was the guys who did the force rebuilds.
Yeah.
Yeah. He said, do you know what drove the performance gains with such small row groups? He said, is it mostly batch mode processing that enabled those kinds of speed ups?
That's right. So yeah, I think so. Think of this, right? Batch mode processing gives you at least 4 to 6 times better query performance over without batch. And the reason I'm making that statement is because we have a trace flag. SQL Server users know about trace flag. So there's a trace flag, which is, of course, you can turn off batch mode processing. We don't recommend that, right? So you can turn off and see the query performance before and after. So batch mode is a big deal. Aggregate push down is a big deal. So some of those improvements, yeah, so it is good. So I think think of this, right? The unit of process is like a row group. Now, so at that level, I'm thinking that if you have 1,000 row groups versus 10 row groups, the query that you're running across all row groups will be much faster with 10 row groups, because you see what I'm trying to say? Yeah.
Yep.
So it is that much faster. Yeah.
Eugene asks, if someone understands how the analysis services tabular engine works, how much of that knowledge transfers to SQL column store and vice versa?
Right. So Eugene, that's a great question. So think of this, right? This analysis services is a great modeling tool. I mean, you can model, I have not used the technology at a level where I can say I'm expert, but you can model a lot of business scenarios, stuff like that. Now, when you run the query, most commonly customers have used this, multi-dimensional model where you pre-aggregate the data and then you just run queries on those things. And the reason the pre-aggregation was done, because the native technology inside SQL engine or Oracle engine or whatever you name it did not have the features that could run the query at a level where I can get response in seconds, right? So they had to pre-aggregate the data, put in multi-dimension cubes, and the 90 report will just run those guys, and then you get the results back, right? Now the challenge with that one was, if I wanted to do drill down, or if I wanted to do something else and there's no cube, I have to contact my DBAs or whoever guys are. And what I've heard, I mean, I could be wrong here, it can take weeks before your query can be run because they have to pre-aggregate the data the right way. Okay. So that was a model. I know in 90s I used to work for Sybase, and it was like that, right? Now with the column store, people are questioning, do I really need to pre-aggregate? If I can run the query 100 times faster, it's good enough, right? So analysis services in 2016, they have a tabular model. You know about that. What they did was they have a direct query mode, right? And the direct query mode with analysis services 2014 did not generate good SQL queries. I would say, I can write a bad SQL query and I can write a good SQL query for the same result, right? So the queries in many cases were not optimal. And of course, if you give a bad query to SQL optimizer, it can do something, but cannot change it dramatically, right? In many cases it can, but the point was the quality of the query was bad. So in 2016 of analysis services, they improved the quality of those queries. And what they ran was, they ran this on SQL Server 2014. This is an interesting point. I hope I get it right. They used SQL Server 2014 engine, okay, with Columnstore. And they ran the workload with analysis services 2014 in direct query mode, as well as with 2016 analysis services in direct query mode, and they got between 5 and 15 times faster results, okay, because the queries were much higher quality. Okay, so the point I'm making is the SQL Server 2016 analysis services direct query mode gives you much better query performance because of the quality of the query, and that combined with the column store, in many cases people are saying, I will move away from storing the data in pre-aggregated form in the analysis service cache. I go to direct query mode. And the beauty of that one is, I just want to answer in a very long way, the beauty of this one is, when you pre-aggregate the data or you load data from SQL Server onto analysis services, there's a latency in the analytics, right? Because you have to move the data from ETL to the data warehouse and then from warehouse to the cube. Now, the direct query mode, you can query the data as soon as it lands into the data warehouse, and you can, slice and dice to the lowest fidelity. Right? Granularity. Yeah. So I think our recommendation is for people to definitely move to direct query mode. What I've heard is those kind of modeling is a lot more chatty, which is not going to work very well. So some customers I know have done it successfully. And in the case of Damon that I showed as an example before, they in fact are running direct query mode. They're not using analysis services. They have these complex queries that are generated by their GUI tool or the application tier, and they're directly turning it into the column store, and the performance is pretty good.
Yeah, it's a great testament to the work that the team did, that so many people have been happy directly just dumping any kind of data warehouse and going, forget it, let's just query the data live, and it's worth it.
It's worth it, yeah.
Well, thank you so much for your time today, Sunil. Really appreciate it. Excellent presentation. People are welcome to give virtual applause now over on Slack.
All right. I can hear it. Thank you.
There we go. Thanks, everybody, for hanging out with us today, and we will see you guys over at the next GroupBy.